Hello. Michael Segal told us about dynamic networks today. And what is so specific about this type of networks that makes them different from any other?
So these networks are networks without predefined infrastructure. So these networks are created on site without any specific equipment. And in fact, every member of this network can serve as a router for the others. So this is the main difference from the traditional networks, wireless networks.
Okay, so if I get it well, one of the possible utilization areas is vehicle sensor networks, right? So
vehicle networks.
Vehicle networks, okay. Yes. And so where one car is trying to communicate, talk with other cars driving around. So you showed us that how in such networks you divide the whole group of cars into subsets just to...
Correct.
Yeah, but what if there is really low traffic?
Well, if it's really low traffic, then you don't have many problems. Mm-hmm. So if you don't have traffic, it means that the distances between cars are very large. So you don't have to be worried about the collisions. So you can drive freely. Usually these networks were invented for the situation where you have high traffic conditions or medium-high traffic conditions when you should be aware of some obstacles. For example, the vehicle is braking before you, and in order to exchange information between vehicles. So if the road is quite empty, you don't have problems.
Okay, well, I was thinking about a situation when the traffic is not that big at the moment, but somewhere in front there was an accident or the weather conditions are changing. So actually,
so if you have a situation when somebody ahead of you knows something about the accident or change of weather condition or some obstacle on the road, when you will arrive to this car proximity, this car will transmit you about this situation. So the transmission will be at least 100, 200 meters before you arrive. So your car will get this information and you can act accordingly. Okay.
And in the opposite situation, when you have really heavy traffic, so I don't say it's a total traffic jam, but heavy traffic conditions, 3-4 lanes in the same direction. How to choose which nodes, I would say, which cars are to be chosen for communication and which are not the best.
So if you have really huge traffic jam, according to our solutions, there is no difference between what you will choose because you will obtain the similar solutions. So the idea is to start with a road with normal conditions and not to allow to get to the traffic jam. So this is the algorithm that suits for it. So you start from normal situation, and your goal is to not allow the bad situation. So you start from normal and you keep the normal situation.
Yeah.
Okay. So if you start from the bad situation, the algorithm probably would not help you.
Okay.
Okay.
Right. Okay. So, are there any other utilizations than just improving the traffic?
So you mean in context of vehicular
network? No. In context, in general.
In general. So there is a situation when you perform sensors monitoring, and you would like to monitor some area. It can be the temperature, or it can be just to check whether some intruder entered the area. So you can use algorithms that I explained for data gathering in order to obtain this information very efficient and very fast. You can also use these techniques to find solutions for the flying drones, to maintain the swarm of flying drones that perform some specific task.
Okay, so if I get it well, with those drones, you have not one drone, but
yes, a swarm, a group of drones.
A group of them, and you can steer them and control them, and not from further distance, because you just they communicate one with each other.
Yeah.
Right?
So the idea is that you would not control them. So the idea is that you look at them as a swarm of birds. Okay. So they you just tell them the goal that they need.
Okay.
For example, they want to track some cars at the ground.
Right.
So suppose you have like 10 drones, and you tell them, okay, track me 5 cars. Okay. So these drones should be connected between each other, and they should, as a group, perform the operation of tracking. But the decisions who will track which car are performed by the swarm itself. Okay. You don't control it by distance. Okay, so just give them. So it's kind of also machine learning, artificial intelligence, distributed solution, which they are communicating with each other.
Right. When I hear about so many small, I would say, sensors included in so many different elements in cars. Well, drones are not that common, but quite probably it is going to be in any other objects. I don't know, buses, etc.
Correct.
Right. Well, a concern arises about privacy.
Right. So of course, the next step in improving the solution is to think about the mechanisms that will provide and solve some security issues regarding these sensors. And this work is in different area. It of course connects with the work that we have done, but this work is an area of cybersecurity, Internet of Things, and I believe that it will be developed very fast in the next several years.
Okay, and maybe how do you see the future of that solution?
The future of security solution?
No, of the
well, the future, I think, is everything is connected, Internet of Things. So you can drive in your car and make a command to open your apartment from your car, and make some appointments with with other structures, and probably the future is that from every point in the world you will be able to do almost every operation that you can think about it.
Sounds
electronic operation.
Yeah, of course. Sounds intriguing, I would say, and but at the same time, well, I'm not that sure if it's going to be that safe, I would say.
I don't know if it's going to be safe. It should be safe.
It should be.
It should be safe, and I hope that if people are moving in this direction, then the appropriate solution for the security will be developed.
Yeah, definitely it should be comfortable, easy.
Yes.
Because it sounds to be good in this direction, but if something is easy to use and comfortable, then at the same time, very usually there are some security concerns.
Of course.
Yeah. Okay, so thank you for this conversation.
You're welcome. Thanks for inviting me to this conference.